welcome to Module 5, Lecture 1 of Applied Database, COP4708. I'm your Professor Dr. Ron England, and today we're going to talk a little bit about data modeling. We're going to start getting into the guts of how to model stuff. So, what is a data model? Well, when you're dealing with data, you got to figure out how you're going to arrange it, put it all together. So, we really start with this concept of abstracting the concepts of the actual data, and we use it to design the database. But some people like to jump right into database design, and many times, simple databases, it's easy to do. But a lot of times you kind of need to look a little bit more and really actually ask questions about the data to understand the relationships in the data so that you can better design a database. So they've been around for a while. It's a number of different symbols that are used by different methods of data modeling. The IDEF1X is a NIST standard, typically used a lot, and also UML. So UML actually has the ability to go into good old object-oriented type of methodology, which can be modeled in an ER diagram. In entity relationship. So we do ER diagramming in two directions. Sometimes we model in the positive direction, where we build a entity relationship model with the ER modeling methods, and then build the database from that. And you can also go the other direction so that you can actually better explore the model. So first, one thing you must understand is the concept between an entity class and an entity instance. When you design your database, you're designing those entity classes. You may use instances of the data to help you better understand the class, but essentially think of it as the instances as rows in the database. You can have lots of those. The class defines how they work together. So it's pretty straightforward here. If we were looking at a customer entity, you have things like street, city, name, zip. When you look at the instances, those are actual values that you put in there. Which is, I think, from the slide, is really self-explanatory. So, and then we get into the concept of attributes, where you saw the entity there. The attributes are all those different descriptive things that are in there. You might see some old versions of ER diagramming where we used them as ellipses. Just don't. Ellipses aren't really good for putting text in. So now we pretty much do it in rectangular form format. So there's the old ellipse format. Ugh, yuck. And then there's the actual way that we typically represent the entity now with its attributes right there with it. Much, much cleaner. So if you feel like you're going to do this, don't show it to me. I don't want to see it. That's just that simple. Use this format. All right, so you've got the concept of things, you've got entities, and you've got the attributes. And some of the attributes can be used to identify the entity itself. Okay, we've seen that in the past. And you've got the concept of composite identifiers, where you got more than one attribute that are used together to identify the entity instance. So we use those, and we say in the database, we actually call those the keys. We talked a little bit about already the concept of primary keys and foreign keys. So primary keys inside of a table, the primary key would be that value of that attribute that identifies the entity. And the foreign keys identify relationships between that specific entity and other entities. So here, pretty straightforward. You've got here's an employee, that's an entity, and a bunch of attributes. An employee with only the identifier, and then the employee with no attributes. Okay, very straightforward. You can see it, and when you're drawing it, this is exactly what it would look like. When you're actually putting these onto paper as diagrams. Now, here's where it starts. That stuff is all pretty simple stuff. You define the entities and you define the attributes of the entities. But now's where we actually get to have a little bit more fun with this, because entities are going to be related to other entities. So, and part of this is just defining how those relationships work. So, we're going to talk about, well, we don't really use this a whole lot. We talk about the degree of a relationship. So, if two entities together have a binary relationship, there's something that relates the two. Three entities have a ternary relationship. Those two types of relationships, the binary and the ternary relationships, are the ones that you're going to find most useful. Therefore, you're going to find those to be most common because they're just simply useful. All right, we move onward, and you can kind of see how we're actually indicating ternary and binary relationships. Now, one of the things we're going to talk about a little bit is concept of cardinality. And we sometimes deal with maximum cardinality, but the reality is we mostly only really work with minimum cardinality. Okay, that's the number of entity instances that must participate in a relationship. And then really most of the time it's only going to really deal with 0 or 1, basically saying that you have to have 1 to make the relationship work. And you're going to see that better with an example. In the concept of maximum cardinality, that is really when you say you've got a 1-to-1 relationship, okay, and you're going to design so that in cases where you have 1-to-1 relationships between two entities, that you're never going to have more than 1 there. And then 1-to-many and many-to-many are the ones that you're going to model a lot. That's really where you get down to the guts of modeling. And let's kind of look at some of these, look at this in a little bit more detail. So in the case of a 1-to-1, this is a great example. An employee will really only have, and this might be 1 badge number. In 1-to-1 relationship, the thing is that you could potentially include it as an attribute. But the reality is in many cases, you're going to need to break it off into its own entity. A 1-to-many relationship, well, employee can have multiple computers. That's a decent example. 1 employee, many of whatever that other thing is. And each of those, the employee will have a series of attributes, and the computer will also have a series of attributes that go with it. And in the many-to-many relationships, you have employees that have a skill, and if you have a list of skills and you want to know what employees have that skill, that's a really useful thing to have. And you'll see that often as an N-to-M or an N-to-N. You'll see both of those types of ways of indicating this. So in the 1-to-many relationship, we talk about the concept of a parent entity, in this case, the employee, and a child entity, in this case, the computer. So I just want you to be used to the actual terminology that is used when you talk about the relationships between the different types of entities, parent and child. And that one kind of should seem a little bit obvious. So there's really, in the case of has a and is a, and that's what we call them, has a relationship. That was the example that we just had. An employee has a computer. So you can call it a has a relationship. And the modeling of has a relationships and is a relationships, you're still going to have to model them with tables and relationships, but you're going to look at them slightly different in how you actually build the data models to them. But it's really easy to look at something and say, this is a has a relationship. I have multiple computers. I have this computer that you're watching this on that's out of my house. I've got my computer at work, and I've got my mobile computer. I have 3 computers. Those are has a relationships. And minimum cardinality, which is where you get into the design, the minimum cardinality is one that you will be working with, and that's the one that really requires a certain amount of modeling. The maximum cardinality also has a play, but we're really talking about three things there: the one, the zero, one, and n. And here we've in the minimum, we've also got the, you either have to have something to participate in a relationship or don't. So really what you're talking about is optional versus mandatory participation for the entities to work together. And so a mandatory relationship, employee must have a badge. Okay? An optional, the employee may have a computer and the computer may have an employee. It doesn't have to have an employee. I mean, a computer doesn't have to have an employee doesn't have to have a computer. And then in the case of optional to mandatory, well, this was pretty obvious. Employee, and you can have skills with no employees theoretically, but the reality is you're probably not going to track those skills if there's no employees to go with it. Or you can say employee cannot be in the database unless it has a skill. So unless they have a skill. So for those entities to exist, you can have an optional or a mandatory on either side of that. We use the little single line to indicate mandatory, and we use the little 0 to indicate optional. Okay, pretty straightforward. ID-dependent relationships, those are when you have to have a little bit of information about the parent for the child, and you're always going to have a cardinality from the to the parent of 1. Basically, you can't have an instance of the dependent entity without having an instance of the parent entity. So, for example, you can't have an apartment unless you got a building for where it goes. You can't have the painting information if you don't have a painting. You can't have a patient exam or exam results for a patient that doesn't exist. Okay, it's ID dependent. And what we do is we have an identifying relationship between the entity that is the child entity and the parent entity. So in other words, when you're talking about the apartment itself, you keep some piece of information in that entity that identifies the building that it belongs to. And the same for all three of these examples. All right, weak entities. Well, you just saw some examples of weak entities because the existence of the weak entity depends upon another entity existing. And ID-dependent entities are going to pretty much they're always going to be weak. You've got to have that ID to be able to tag it to connect it to that other entity. There will be situations where you're talking about the other one, which is strong entities that don't have that dependency. So in this case, you've got the auto here, which is a weak entity because the existence of the VIN depends upon the manufacturer's model. It has to exist there. But we also just showed you three other examples. Subtype entities, okay, and that's a situation that's really common. So we can say you have an entity that is a student. Well, there's multiple types of students, and sure enough, the type of student could be an attribute, but you may want to have that attribute actually be an entity itself, because you may track totally different information in this case that are be attributes of undergraduate students and attributes of graduate students that are different for the two. So in this case, we've actually got a discriminator between the different attributes here that make them their own separate entity. So even though gender would typically be an attribute for a patient, you also may have in that situation different types of information that you would track for people of those different genders, and you would throw a discriminator in there for those different subtypes. And as you can see, none of this is really that complex in that it's actually just common sense in how we deal with the world. But at the same time, when you're trying to build a good way of managing the data, you need to understand and put down how these all work. So You've got the concept of exclusive. Okay, one supertype relates to at most one subtype, or inclusive, where they can relate to one or more subtypes. Okay, so in that case, and again, you're going to do this by drawing it and actually putting it out. So you can look at the situation here where you've got an employee, and the situation in the first case is if it's an exclusive, the employee can either be a manager or be a database administrator, but can't be both. And in the other situation, you're saying, well, it's actually going to be inclusive. We can have people that can be both. But you're going to come up with scenarios where you're going to have both the exclusive and the inclusive. You're going to have it can be both, or it might not. Might not be able to be both. And essentially here, it's making that decision of whether it is or isn't, and then modeling it. And that actually brought us up to the concept of, we did quickly talk about has-a relationships. Now we're talking about is-a relationships. So let's look at that. Well, you kind of already saw an example. Well, we saw an example is right there. Those are a manager is an employee, the DB admin is an employee. Right, so, okay, and what you're doing is you're saying in the concept of an ISA, the identifier is the actual same thing. So if you create an entity for manager, or you create an entity for DB admin, well, the employee's identifier is employee number. Well, the identifier for the manager will also be the employee number. So they use the same identifier. And it's simply that is a relationship. All right. Now, talking about strong entity patterns, we talked about weak entity patterns. Strong entity patterns just basically means that it can stand alone without actually having to be connected to the other entity. So this is a good example. Club members would have a locker, but lockers can change from one club member to another, or you could actually have they can exist independent of the club member. So they don't have to have a club member to exist. Right? So moving onward, you've also got this entity patterns where you've got a one-to-many relationship. So and again, I'm going to let you work through these. There's plenty of different examples of the one-to-many relationships, and we were just doing a whole bunch of them, right? I mean, we had a whole lot of examples there, and another one there. So straightforward. Many-to-many. This is the one that throws a lot of people in the modeling world, because in the one-to-many relationship, when we typically model it with a database, we have three entities. We have the two entities that have a relationship, and then we actually model a relationship table for the relationship itself. So are they common? Oh, they're definitely common. And they can be both strong and weak. But in this case, we're just showing an example of weak. In this case, we're showing examples of strong. Okay. They can exist independently of each other and still have that relationship between each other. So, in a quick review, and this is much better done by simply working through and looking at a domain and developing relationships. One of those first things that I typically do is look at the has-a and is-a relationships. And then the next thing I do is I look at the dependence of the entities upon each other. And then one of the decisions that you've got to make in database design when you're doing this, and the ERD helps you out, is the cardinality. Okay, must I have another entity to have an entity exist? or not. And, and here's a good example. I've got multiple phones. And so I have a one-to-many relationship with the phone. I have my cell phone, I have my work phone. Let's just go with those two. But that is two phones. So I could create an entity of phone and have a one-to-many relationship between myself and the phone when I'm modeling it. Or I could say, you know what? I'm just going to put in to my employee, me or whatever person, cell phone, work phone as attributes. And that's a decision that you have to make in the design. So in many cases, you are making a decision of, is this an attribute or is this an entity? So that's where we're going to leave it, and we're going to get an opportunity to discuss that. And here's one thing that will confuse a lot of people. In many of the cases, there is no one right answer. Okay? And what I don't mean is there's no one right answer in the cardinality, or one right answer in is it an is-a or a has-a, or whether the entity is weak or strong. There's no one right answer many times in how you model it. And that phone example is a very good example of that. Can you say the correct answer is model the phone as a separate entity, or keep it as an attribute within the table that's my table? Guess what? There is no one right answer. So, and that does take us back to the whole concept of normalization. I hope that everybody enjoyed this, and I'm going to talk about that no one right answer later when we're actually doing some modeling, because it kind of depends on how you're going to use it, the best way to model it. Thank you, and on out.